Hi everybody, I'm here doing the problem that we did in class today. As it turns out, I did it correctly, so I'm going to redo it here. A stone is thrown vertically upward from the ground at a speed of 40 meters per second at time 0. Its distance, d in meters above the ground, is approximated by the function f of t equals 40t minus 5t squared. Okay, so like I did in class, I drew a picture, just kind of saying this is the ground, and then at some time t, it's at the ground. At the top here we have the stone, and then we're trying to see, well, what's the range of this time? We don't know what that time is. So this here is the distance that the stone is thrown, and they said that that's f of t as given in our problem. So f of t is equal to 40t minus 5t squared. Alright, so why I thought I was doing it incorrectly, I didn't utilize the 40 meters per second, but really I don't have to utilize it because we have distance equals rate times time. Our rate is equal to 40 meters per second. So that happens when t is equal to 0. So this is not necessary because all that tells me is that the distance is equal to 40 times time, which is 0, which is gonna give me 0. So all that's saying is that when the time is equal to 0, the distance is going to be equal to 0. And that is consistent with our formula. Notice if I plug in 0 for t into our function, f of 0 is equal to 40 times 0 minus 5 times 0 squared, which gives me 0. So, like I said, that's not necessary to do the problem. We need to just proceed the way I proceeded in class earlier. Remember that distance is always positive or 0. So that means that the function f of t has to be greater than or equal to 0. Which means that 40t minus 5t squared has to be greater than or equal to 0. As we did in class, the way you solve this is that at first you treat it as if you were setting the equation equal to 0. So 4t minus 5t squared equals 0. We can do that by factoring 5t. We're left with 8 minus t equals 0. Setting each factor equal to 0, we get 5t equals 0, or 8 minus t equals 0, which means that t is equal to 0, or t is equal to 8. So we got this far into our problem. These values 0 and 8 separate our number line into 3 intervals. And what we do is we're going to take some test values from our first interval, which would be from -infinity up to 0. And then we're going to take a test value from our middle interval, which goes from 0 to 8. And then we're going to take a test value from our last interval, which goes from 8 to positive infinity. And because we're including, it has or equal to here, I'm going to use brackets, close brackets on these numbers, because it is possible for the 0 and the 8 to be included. So let's pick a test value that's in the interval from negative infinity up to 0, like negative 1. If I take negative 1 and plug it into our function, I get f of negative 1 is equal to 40 times negative 1 minus 5 times negative 1 squared, which gives me a negative 40 plus, that's going to be minus 5, which gives me a negative 45. So what that means is I cannot take anything from that interval. This interval does not work. Because remember, my goal is I need this value to be greater than or equal to 0, and it's not. Now we're going to check the middle interval that goes from 0 to 8. So I'm going to pick a value in here, let's say maybe 5. So f of 5 is equal to 4 times 5 times 5 squared. I end up with 40 times 5, which is 200, minus 125, which gives me 75. Well, that's greater than or equal to 0. So we want to take this interval. So I know that's part of my solution. Lastly, I'll check the last interval. I'll plug in a 9. So I get 40 times 9, which is 360, minus 81 times 5 gives me 405, and 360 minus 405, it's going to give me a negative number. So remember, we want this to be greater than or equal to 0. It's not, so I cannot take that interval. So the only interval that works goes from 0 to 8. So our domain is the interval from 0 to 8.